So what we did the other day is we started working with finding ways to tell if triangles are congruent, right? So what we worked with the other day, we're looking at, and I'll just write it here, SSS and SAS, right? And SSS stood for side, 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 SAS stood for side, angle, side. These were two ways to tell if triangles were congruent, right? There was a third way that we talked about that wasn't congruent. And the reason that ASS wasn't congruent is because ASS, the angle wasn't between the sides. The angle needs to be between the sides for it to be congruent. That's why if it's ASS, it's not congruent, right? So we learned those two ways to tell that triangles were congruent. What we're gonna work with today is we're gonna work with three other ways, right? Because altogether there's 5 different ways. Today we're gonna learn third, fourth, and fifth way. So the third way that we can tell if triangles are congruent is by ASA. And what ASA stands for is literally angle, side angle, right? And they literally need to give us those parts. They also need to give us them in that order. So we have angle, side angle for ASA. And what ASA represents is, again, you're gonna have 2 triangles, let's say, right? We have this here, we have this here, let's say, right? And again, now I'm making them, let me draw a better triangle. Let me draw better triangles for you just so they don't look crooked. So, there. Let's do it like this. Easier to see, easier to analyze as well, right? So let's say we have 2 triangles that we're trying to show are congruent. And again, if they're congruent, it means that they're gonna be exactly the same in every way. Corresponding sides are all the same, corresponding angles are all the same, everything about them are all the same, right? For it to be ASA, what we need is 2 angles and a side, right? So we'll start off with the 2 angles, right? Let's give you an angle here with a curve, 1 curve. So that gives us an angle, right? Let's give us here another angle. Doesn't matter where, I'm just putting them anywhere for now. Put 2 there, put 2 there, just to show that they're different. So this and this are the same, right? So we can label that with an A. Let's call that A, because those 2 are the same. We can label this with an A, because those 2 angles are the same. Now what we need for it to be ASA is that we need a side, right? And not only do we need a side, we need the side to be between the angles. We need the side to be between the angles. So where we would have to put it would be here. We would have to put the side there. Because if we put the side here and we put the side there, automatically if those 2 sides are congruent, we see that now we have a side. And more importantly, we know that that side is between those 2 angles. For it to be ASA, the side needs to be between those 2 angles. This side needs to be between the angles. And once you have that side between the angles, automatically you know it's congruent by ASA, right? It's ASA congruent. And that's what ASA means, right? It's going to be 2 angles, a side. The side has to be in the middle of the angles, right? And if that's true, if you have ASA, we know that those 2 triangles are congruent, right? So that was ASA. We also then have something called AAS. And again, now that you guys are getting in the hang of it, you can figure these out most likely by yourselves. And it's good because you start seeing also how they're all different from one another. We also then have AAS, right? AAS again stands for angle, angle, side. And some people are going to notice it, some people may not see it right yet. But there is a big difference between angle, side, angle, and angle, angle, side. And the difference is for it to be angle, side, angle, the side has to be between the angles. For it to be AAS, the side now is not between the angles, right? It's not. That's the main difference. ASA, the side's between the angles. AAS, the side is not between the angles. So now if we wanted to draw this again, just to be able to see what it looks like, and we have 2 triangles, right? 1 triangle there, another triangle there. And right now, we don't know that they're congruent because we don't have any corresponding parts. We don't know what's congruent to what. We don't have any angles, we don't have any sides, none of that, right? But let's focus on it, right? So for it to be AAS, we need, again, we need 2 angles. I'll put 1 up here, so 1 and 1, right? And then I'll give us, here, I'll put it here, 2 right there. I'll put 2 right there, right? So now once I start looking at this, I know now that those 2 represent an angle, right? I know that these two represent another angle. Now think, we want it to be AAS, right? For it to be AAS, the side cannot be in between the angles, right? We need the angles and then we need the side. So we can start thinking, where can we put these sides, right? So now if we wanted to, if we were to put it right here, that wouldn't be any good, because if we put it right there, the side would be between the angles. We don't want that. We want the side after it. So if we want to, we can put the side there, we can put the side here. Doesn't matter, as long as it's not between the angle, right? Because now if we look at this, we see angles are right there, side comes after, right? Because this side now is not between. For it to be between, it would fall here. Instead, it's there. And once you have that side is not between, that's when we have AAS congruence. AAS congruent. Because right now, the side is not between. That's the main difference. For it to be AAS, the side comes after. And then the last one, which is the one that's completely different from all of these different types of congruence postulates and congruence theorems, it's one that's called HL. And first, it is different just in the way that it looks, right? HL, what HL stands for is hypotenuse, leg, right? And the main difference already why HL is different from everything else, HL is the only one where the triangle needs to be 90 degrees. If it's not a 90-degree triangle, it can't be HL. So it needs to be a right triangle for HL. Automatically has to be. Must be a right triangle. And the difference is all the other ones, they could be right triangles. They don't have to be, but they could be. HL, it needs to be. If it's not a right triangle, automatically we always know it can never be HL. HL has to be a right triangle, right? So that's the main difference right there, but then we're also going to go into what H and the L stands for. So like I said, for it to be HL, the first thing it needs to be a right triangle, right? So we need to give you a right angle, because now once we see that, already, that's the first thing we need for HL. Has to be a right triangle, right? And just because it's a right triangle doesn't mean that it's HL. It's the first thing we need. So you see, for it to be HL, we need a right triangle. The H stands for hypotenuse. And what a hypotenuse is in the triangle is the longest side of a triangle. And when we're looking at it, the longest side would be right there, right? And then we're also going to go into this when we start analyzing triangles more in another unit. But the longest side, the hypotenuse, is always opposite. It's always across from the right angle, right? Always. If the right angle is right here, the hypotenuse is always across from it, right opposite. So, again, for hypotenuse leg, we need a right angle. We need the hypotenuse to be given. We need the hypotenuse to be congruent. And then with the leg, it's just any other side, right? As long as they give us another side, so it could be either this side or this side, as long as they give us another side, automatically we know that we have everything. So for it to be HL, again, first thing, needs to have a right angle, which we do. It needs to give us the hypotenuse, the longest side, and it needs to give us any other side. It could be this side, it could have been this one, it didn't matter. Because the second you have this, right, automatically it becomes HL. And again, just always remember, guys, almost go through a checklist. HL, we need a right triangle, right? We need the hypotenuse, and then we need another leg. Just don't ever think that it always has to be the one at the bottom, could be the one at the side, doesn't matter, as long as we have any other side. So these are the 5 that we have, right? There are 5 ways to tell that triangles are congruent. Okay, we learned 2 the other day. We just went over 3 now. And I just want to list them again, just so you guys see it. Just always remember, 5 ways to tell triangles are congruent. SSS, SAS, AASA, AAS, and then HL. And out of all of those, the only one that's different from each other is HL, because HL must be a right triangle. It's the only one that has to be a right triangle. Everyone else, it doesn't matter what kind of triangle it is, but HL has to be a right triangle. So now let's just do 5 practice problems, guys, just to see if you can get the hang of these, right? So again, all I'm gonna want you to do is I'm gonna show you 2 triangles and I'm gonna want you to tell me whether they're congruent, by which way or not congruent, right? So I'm gonna draw 2 triangles, right? So we got this. We have that right there, right? I'm gonna give you, sorry, have these drawn down. I'm gonna give you that, right? And then I'm gonna give you this right here. And again, the most important thing, it's always to look at what kind of triangle it is, right? So the one we can already eliminate, automatically, we always know. And I'm gonna write them up here just so you guys don't forget them. It can either be HL, it can be SSS, SAS, it can be AAS, or ASA, right? It's gonna be one of those 5 if it's congruent. If it's anything else other than that, it's not, right? And always remember, we always need 3 parts for all of these. So the first one we can eliminate, HL, because for it to be HL, it needs a right angle. We don't have a right angle, we know it's not HL, right? So let's label now what we do have, right? So let's see what we have. So that has one curve, that has one curve, so that's an angle, right? That's a side, label that with a side. That has 2 curves, that has 2 curves, that's an angle. And then we see, it's 2 angles and a side, so it's one of those 2. But the side is between those angles, so if the side is between those angles, we know that it's ASA congruence, right? ASA congruence. Because again, the side is between the angles, so it's ASA, right? Again, just always get in the habit of looking at that, seeing what you guys actually have, and then going from there, right? Try another one. I'm gonna do 4 more total, just to get you guys in a habit of it. Just to get you guys seeing more practice of it too, which hopefully should help out. We have this, right? All right, I'm gonna give you that. I'm gonna give you that, this, and that, right? So now, again, we want to tell if these are congruent. Don't ever just go by the picture, go by the information. So first thing we notice, that has a right angle, right? So if it has a right angle, automatically you guys should start thinking, maybe HL, right? So for it to be HL, we have a right angle, which we need. We have the hypotenuse, which is the longest side. Again, cross from the 90, cross from the 90. And then we have another side that they give us with the 2 tick marks, right? So we have the 3 things we needed. We have a right angle, we have the longest side, the hypotenuse, and we have another side, another leg. All of that automatically tells us, guys, what we know. Automatically, it's HL congruence. And again, always remember, whenever you see a right angle, the first thing that should always go off in your mind is, could it be HL? Not, it's definitely HL, but could it be? And for it to be HL, you need a right angle, you need the hypotenuse, the longest side, and you need any other side, right? Okay, let's keep it going. This triangle, and again, sorry about the horrible drawings, guys. It's just not that easy sometimes to draw straight lines, freeform, and by hand without anything. So we got that, right? So now I'm gonna put one curve here, I'm gonna put one curve there, I'm gonna put another one, 2 there, I'll put 2 there, and then I'll put a tick mark there, right? So again, going by what we know, let's go off everything that we see, right? First thing we see, we have a curve here, that's an angle, right? We have 2 curves there, we have 2 curves there, that's another angle. Then we have a tick mark and a tick mark. That's a side right there, right? So now again, we got 2 angles and a side, AAS or ASA, and then ask yourself, is this side between those angles? We see the angles here, we see the side over here. So once it's over there, it's not between the sides, right? It's after the sides. It's after the angles, I'm sorry. And if it's after, automatically we know it's AAS. Because again, AAS tells you that the side is after the angles. And since we have the angles there, the side is outside of it, it's AAS. If the side was here, then it would be between. But since it's not between them, it's AAS, right? 2 more, guys. All right. Let's look at this one here, right? And again, just to make sure that you guys actually see this, because this is an important concept to actually have. You have 2 triangles, right? And some of you may already see it automatically, some of you may not see it yet, it's okay. But again, let's always go with what we see, right? And then go from there. So let's look at that, right? We have this. Now what we have is that we have 2 triangles that are together, right? They are separate, and then we have them together sharing a side. So looking at that, we see this angle and this angle, one curve, so that's an angle. We have 2 there, that's another angle. And then some people would say, you know what, we're done, we have nothing else. But that's not true, because the fact that these triangles are together, we see that they're sharing this side right there. And the fact that they're sharing this side, even though there are no numbers, the fact that they're perfectly next to each other and perfectly on top of each other, we know this side here is going to be congruent too. We know it's congruent because, again, whenever they're together, even though there's nothing written, the fact that they're together shows us that they're exactly the same. And if those sides are exactly the same, here's our side. So now again, looking, AAS, ASA, we have 2 angles, and now we do have that this side is between those angles. The fact that it's between them, we know it's ASA automatically, right? And we know again, it's ASA because we have 2 angles, and the side is right between them, right? The fact that that side is between the angles gives us ASA, right? Let's do one more, guys. Again, hopefully you're getting the hang of it. Hopefully it's becoming easier to see as you're doing more and more practice with it. If not, again, we're just gonna keep practicing all the time until you guys get better. And always look out for it. Once you guys actually see that sides are together, automatically you always know and should think ASA or AAS. Or think SAS, because we have that extra side. You know what I mean? So we have this right there, right? And again, last time, let's go over what we have. So we have a curve and a curve, right? Automatically, that's an angle. We have 2 curves and 2 curves. Automatically, that's another angle. And now again, some people would say we have nothing else, but look. Whenever this side is here in the middle and they're together, automatically we have that side right there, right? And then let's ask ourselves, we have 2 angles, right? Here and here, and we have this side that's not between them. If the side was here, that side would be between them. The fact that it's not there, it tells us that that side is after, right? So if we have 2 angles and then this side, we know automatically it's AAS, right? AAS congruence, guys. Just always get in the habit of seeing it. If you see 2 angles, ask yourself, is the side between? If the side's between, ASA. If you have 2 angles and then you have a side that's not between them, because again, if we have these 2 angles, between would be right there. But it's not right there, it's down here. So always check that, guys, and always remember, out of those 5, HL is the only one that's different, because HL is the only one that has to be a right angle. Take care, guys. All is well.